In this recording, we're going to look at Lesson 3-4, Data Analysis with a Box Plot. To do this, we need the 5-number summary, which is composed of the minimum, quartile 1, median, quartile 3, and maximum. Now recall, that is the last 5 values. Whenever you put a list of data into your calculator, and you calculate one variable stat on that list, those are the last 5 values that show up. And we're going to use this 5-number summary to in a graphic representation with a box plot. So for that, we have some steps listed here. First, we have to have the summary. Then we draw a horizontal axis with a scale. Just like with all our graphs, we want to make sure we're using a scale that will go from the minimum to the maximum values. That will include that. Then we're going to draw a box whose edges of the box are going to be quartile 1 and quartile 3, and then a vertical line through the median. And then we're going to have whiskers on this box that go from the minimum value to quartile 1 and from quartile 3 to the maximum value. So let's try a problem. So this is our example. The number of meteorites found in the 10 United States is 10 U.S. states is shown. Construct a box plot for this data. So remember now, we've got to have that 5-number summary. So either you need to type this in list 1 and calculate one variable stat to get your 5-number summary, or you need to arrange your data by hand, least to greatest, find the median value right here, this 83.5, that's the middle value of the data. Separate your data into 2 parts, and the middle of the first part is 47, the middle of the second part is 164. Those are your quartile 1 and quartile 3. And then, of course, the minimum value is 30, the maximum value is 296. So to follow those steps that were mentioned on the previous slide, the first thing we need to do is draw a horizontal scale. I'm going to try. So we're going to draw a horizontal scale. Oh, gracious. And we've got to include that minimum and maximum. So I'd probably start my scale off here with 0. Maybe since I've got to go up to 296, maybe mark it off in hundreds. 0, 100. Try to equally space this out, 200. And one more time for 300. And then identify these points. So above the scale, where I'm estimating what 30 is, I'm going to place a point, and I'm going to say, okay, this is 30. That's my minimum value. And where I estimate 47 is, I'm going to place a vertical bar. That's going to be one side of my box. That's at 47. And then estimate where 83.5 is. So I'm just going to estimate here, somewhere along in there. 83.5, another vertical bar. And then at 164, kind of estimating here. Sketch that in. And then a point at 296. It's probably a little bit closer than that. But anyway, give you an idea. So our box goes from quartile 1 to quartile 3. That's our box. So 50% of our data lies between 47 and 164. And then our whiskers go from the point to the box. That's another 25% of our data. And from this quartile to the maximum. That's another 25% of our data. So looking at a little bit better graph than that, in this screen, that's what our final box and whiskers graph looks like. Now, one of the things that was mentioned in the previous lesson was how to determine if a number is an outlier. So let's go back to, let's see the question here. This was our data. We had these values, and we want to know, is 296 an outlier, that maximum value? So the way we determine that is First of all, we determine the interquartile range. Let's see if I can find my little doodad. And to get the interquartile range, we subtract quartile 3 and quartile 1. Well, in that previous problem, these were our two quartiles. So we subtract this, and this gives us our IQR. And to test for outliers, we use 1.5 times the IQR. So 1.5 times that number gives us 175.5. And our next step is to subtract that value, that 175.5, from the lower quartile, and that gives us our lower boundary, and that's not right. Ignore that. We'll do that arithmetic in a minute. And then to add that to our upper boundary. Let me check the arithmetic here. 7. That really should have been 128 negative 128.5. And so our question is, if any values fall beyond these boundaries, this negative 128.5 and this 339.5, if any of our data is beyond that, then they are outliers. Well, let's look at our data. Do we have any data that was beyond that, that was less than negative 128.5, or that was greater than the 339.5? No, none of our data is. The highest value we've got is 296. But if we went back to the problem and said, suppose the 296 was actually 396. Would 396 be an outlier? And of course, yes, it would, because it's beyond that upper boundary, that 339.5. Now, in our next little video, I'm going to show you how to do this by graphing a box and whiskers plot on your TI-84 calculator.